Okay, this is in continuation with the lesson on radical expressions. So this time you will have to evaluate expressions involving fractional exponents. So the exponents of algebraic expressions are fractions. For example, number 1, 25 raised to the power of 1/2. So obviously, if we are to follow the rule or the concept that a to the power of 1 over n, that would be equal to the nth root of a. So again, a to the power of 1 over n is equal to the nth root of a. So n, which is the index, would be 2, which is no longer written. So kanang 25 raised to the power of 1/2 would be the square root of 25. And we all know that the square root of 25 is 5. Okay. But assuming that we will not be using the radical sign, how do we simplify 25 raised to the power of 1/2, which will still obtain 5? So 25 is obviously 5 squared, since 5 times 5 is 25. So rewriting the expression 25 to the power of 1/2 into 5 squared to the power of 1/2, and then applying the laws of exponents, particularly the second law of exponents, which states that a to the power of m to the power of n is equal to a to the power of m times n. So you simply multiply the exponents. So the exponents in this case are 2 and 1/2. So when multiplied, will give you 1. 2 times 1/2 is equal to 1, since 1/2 is the reciprocal of 2, or 2 is the reciprocal of 1/2. So by the inverse property of multiplication, 1/2 being the inverse of 2, or 1/2 being the reciprocal of 2, when multiplied gives you positive 1. So the exponent of 5 is now 1. So 5 to the power of 1, or simply 5. Next. By the way, this was actually the same exercises which I had to snip from the long quiz which I told you that I gave to grade 8 students 2 years ago who are now in grade 8. Okay. Number 2, 125 raised to the power of 2/3. So how do you simplify this expression? So I would normally think of rewriting the base into an expression such that it is say for example kaning 125, this is actually obtained by multiplying 5 by itself 3 times. So 5 cube. Okay. Raised to the power of 2/3. So as you can see, the exponent of 5, which is 3, is to be multiplied by 2/3. 2/3 whose denominator is 3. Diba? When you multiply 3 and 2/3, you get 2. Or you simply cancel 3. So ang idea ana, you have to express the base, which is 125, such that its exponent will be cancelled by multiplying it with the other exponent, which is a fraction. In this case, that is 2/3. So 3 times 2/3 would be 2. 3 times 2 is 6, divided by 3 is 2. So the base is 5, the exponent is 2. So when 5 is multiplied by itself, or when you square 5, you get 25. So that's 125 raised to the power of 2/3. Next, 16 to the power of negative 3 halves. So, 16 may actually be written as 4 squared. Again, 16 may be written as 4 squared. 16 may also be written as 2 to the power of 4. Again, 16 may be written as 4 squared. 16 may also be written as 2 to the power of 4. So, between the two, which one should we choose? Actually, either of the two, for as long as you do not violate any rule in algebra. That's actually the doctrine in our class, diba? For as long as you don't violate any rule in algebra, it's okay. The same answer will be obtained in the end. We will still agree with one thing in the end. So, pero preferably, I would have to go for 4 squared, since the exponent of in that expression is actually the denominator of the fractional exponent, which is negative 3 halves. So you will have to rewrite 16 as 4 squared to the power of 3 halves, negative 3 halves, I mean. When 2 is multiplied by negative 3 halves, you get negative 3. So you have 4 to the power of negative 3. So 4 to the power of negative 3 is 1 over 4 cubed. That is a to the power of negative n is equal to 1 over a to the power of n. 4 cubed is 160, 4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. Therefore, 1 over 4 cubed is 1 over 64. Next. By the way, another way of doing number 3. Diba, I chose to express 16 as 4 squared instead of 2 to the power of 4. Now, let us try to find out whether or not we will still get the same answer if we go for 2 to the power of 4 as a way of rewriting 16. Okay. So, instead of having 4 squared, I will have 2 to the power of 4 this time. So, 2 to the power of 4 to the power of negative 3 halves. So, the exponents would be 4 and negative 3 halves. So, when 4 is multiplied to negative 3 halves, you get negative 6. Negative 6 because 4 times negative 3 is negative 12. Divided by 2 is negative 6. So, the exponent of 2 is negative 6. So, as you can see, kanina, the base is 4, the exponent is negative 3. This time, the base is 2, the exponent is negative 6. But take note that these two are actually derived from the same given, which is 16 to the power of negative 3 halves. So, still using following the same rule of or law in exponents. So, 2 to the power of negative 6 will then be rewritten as 1 over 2 to the power of 6. Okay, how much is 2 to the power of negative 6? That's 1 over 2 to the power of 6. When you multiply 2 by itself 6 times, 2 times 2 is actually 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So that's 1 over 64. Okay. Number 4. 9 to the power of 1/4 divided by 9 to the power of 3/4. So what does the rule or what does the law of exponents say? When you divide expressions with the same bases, in this case which is 9, you subtract their exponents. Again, when you divide expressions with the same bases, you subtract their exponents. So the bases are 9. So since the bases are the same, you subtract their exponents, namely 1/4 and 3/4. So 9 to the power of 1/4 divided by 9 to the power of 3/4 would be 9 to the power of negative 1 half. Negative 1 half is obtained by subtracting 1/4 by 3/4. Diba? Since 3/4 minus 1/4 is equal to 1 half, therefore, 1/4 minus 3/4 is negative 1 half. Negative 1 half is actually from negative 2 over 4. 9 to the power of negative 1 half may then be simplified further into 3 squared. Since 9 is 3 squared, raised to the power of negative 1 half. When you multiply 2 by negative 1 half, you get negative 1. So 3 to the power of negative 1 or 1/3. So this is the answer. On the other hand, when you multiply expressions with the same basis, you simply add their exponents. So 3 to the power of 2/3 multiplied by 9 to the power of 2/3. So sir, dili ba sila pareha og exponents? So you express 9 with the base of 3. So that's 3 to the power of 2/3 multiplied by 3 squared raised to the power of 2/3. Para pareha sila og bases. But first, you will have to multiply 2 and 2/3. So 3 to the power of 2/3 multiplied by 3 to the power of 4/3. 4/3 is obtained by multiplying 2 and 2/3. So 3 to the power of 2/3 times 3 to the power of 4/3 will be 3 to the power of 6 over 3. 6 over 3 is obtained by adding the exponents 2/3 and 4/3. That's adding fractions with the same denominator. They are similar fractions. So that's 3 squared. The exponent of 3 is now 2. 2 is obtained by dividing 6 by 3. So therefore, 3 to the power of 2/3 times 9 to the power of 2/3 will be 9. Next, let's proceed. Let's proceed. 16 to the power of 1/4. 16 to the power of 1/4. So, 16 again may be written as 4 squared. So that's 4 squared to the power of 1/4. Multiplying the exponents 2 and 1/4 will give you 1/2. So 2 times 1/4, duha ka 1/4, obviously that's 1/2. So 4 to the power of 1/2, or the square root of 4, which is equal to 2. Or it can also be written further as 2 squared, di ba? 4 is 2 squared to the power of 1/2. 2 multiplied by 1/2 is equal to 1. So the exponent of 2 is now equal to 1. Therefore, 16 to the power of 1/4 is equal to 2. Okay, that's one way of doing it. Another way of doing it would be directly rewriting 16 to the power of 1/4 as 2 to the power of 4, which is raised to the power of 1/4. When 4 is multiplied by 1/4, you get 1. So the exponent of 2 is now equal to 1. Okay. Obviously, you still get the same result. Okay. Again, following our doctrine that for as long as you do not violate any rule in algebra, we will still agree in one thing. In the end, the same answer will be obtained. Next, 1,000 to the power of 2 cubed. So 1,000 may be written as 10 cubed because 1,000 has 3 zeros. Diba? 10 is 10 to the power of 1. That's 1 0. 100 on the other hand is 10 squared. 2 zeros. Diba? So 1,000 is actually obtained by multiplying 10 by itself 3 times. And the number 1,000 has 3 zeros as well, which is actually being represented by the exponent of 10. Okay. So that's 10 cubed to the power of 2/3. Multiplying 3 and 2/3 will give you 2. So 10 squared. Therefore, 1,000 to the power of 2/3 is 100, which is 10 squared. Next. 27 to the power of negative 4/3. So 27 may be written as 3 cubed. Since 3 times 3 times 3, or multiplying 3 by itself 3 times is 27, raised to the power of negative 4/3. When 3 is multiplied by negative 4/3, you get negative 4. So you have 3 cubed to the power of negative 4/3 is 3 to the power of negative 4. So, following the rule again that a to the power of negative n is equal to 1 over a to the power of n. So 3 to the power of negative 4 is 1 over 3 to the power of 4. Multiplying 3 by itself 4 times is actually 81. 3 times 3 is 9 times 3 is 27. 27 times 3 is 81. Another way of verifying whether 3 to the power of 4 is really equal to 81, take note that 3 squared is 9. And when you square 9, you get 81. So squaring 9 is actually raising 3 to the power of 4. Since 9 is 3 squared. 2 times 2 is equal to 4, which is the exponent of 3. Again, 3 to the power of 4 is equal to 81. So 1 over 3 to the power of 4 is 1 over 81. So this is the answer. Next, 8 to the power of 1/2 raised to the power of, 8 to the power of 1/2 multiplied by 2 to the power of 1/2. 8 may be written as 2 cubed to the power of 1/2 times 2 to the power of 1/2. 3 times 1/2 is 3 halves. So 2 to the power of 3 halves multiplied by 2 to the power of 1/2. Adding the exponents 3 halves and 1/2 will give you 2 to the power of 4 over 2. Why are the exponents added? Since you are to multiply expressions with the same basis, the rule says you simply add their exponents. How much is 4 over 2? 4 divided by 2 is equal to 2. Therefore, that's 2 squared. The exponent of 2 is now 2. But you read that as squared. 2 squared, which is equal to 4. Therefore, 8 to the power of 1/2 times 2 to the power of 1/2 is equal to 4. Okay. By the way, just a side comment, if you will choose to input this in scientific calculators, since scientific calculators right now have fractional exponents, unlike during our time in high school and in college nga scientific calculators did not have a feature on fractional exponents. Kani siya, kung imong i-input or i-encode mo sa scientific calculators like 8 to the power of 1/2 times 2 to the power of 1/2, it will immediately give you the number 4. Okay. But please, kabalo mo kung kabalo na gipud mo ana, please do not do that, especially during examination. Even if nobody is really watching you to supervise you in the entire duration of the exam. Okay. What matters is what you really learn. Okay, so what I am trying to say is even if there is no aid of the scientific calculator, you will still get the result. At the same time, that is harnessing your skill in algebra. Okay, next, 27 to the power of negative 2/3. So 27 may be rewritten as 3 cubed raised to the power of negative 2/3. So 3 times negative 2/3 is negative 2. So that's 3 to the power of negative 2 That's 1 over 3 squared. 1 over 9. Okay, ito na yung paspasan. Okay, so 20 minutes. So, negative 125 to the power of 1/3. So, negative 125 may be written as negative 5 cubed. Since negative 5 when multiplied by itself 3 times will give you negative 125. Negative 5 times negative 5 is positive 25. 25 multiplied by negative 5 is negative 125. So, negative 5 cubed is negative 125. Raised to the power of 1/3. So, since the parentheses are already utilized, you make use of the bracket. So, 3 when multiplied by 1/3 is equal to 1. Since 3 and 1/3 are inverses of each other. So, the exponent of negative 5 is now 1. So, that's negative 5. So, negative 125 raised to the power of 1/3 is negative 5. Next, 25 raised to the power of 3 halves is 5 squared raised to the power of 3 halves. Since 25 is 5 squared, 2 times 3 halves is 3. So, that's 5 cubed. 5 cubed or multiplying 5 by itself 3 times is 125. Next, negative 8 raised to the power of negative 4/3. So, negative 8 is negative 2 cubed raised to the power of negative 4/3. So, multiplying the exponents 3 and negative 4/3 will be negative 4. Again, when you multiply 3 and negative 4/3, that's negative 4. Since 3 times negative 4 is negative 12, divided by 3 is negative 4. Or you simply cancel the numbers 3. The number 3 in the numerator and in the denominator. So, that's negative 2 to the power of negative 4. Which is further equal to 1 over negative 2 to the power of 4. So, when negative 2 is multiplied by itself 4 times, the base is negative, the exponent is even, the result is positive. Positive what? Positive 16. So, that's 1 over 16. 1 over negative 2 to the power of 4 is 1 over 16. Next, 3 to the power of 1/4 multiplied by 27 to the power of 1/4. So, that's 3 to the power of 1/4 times 3 cubed raised to the power of 1/4. 27 is 3 cubed. 3 times 1/4 is 3/4. So, that's 3 to the power of 1/4 multiplied by 3 to the power of 3/4. When the exponents 1/4 and 3/4 are added, you get 4 over 4. Diba? 1/4 plus 3/4 is 4 over 4. 4 over 4 or 4 divided by 4 is equal to 1. Hence, the exponent of 3 is now 1. So, therefore, 3 to the power of 1/4 times 27 to the power of 1/4 is equal to 3. Last, 9 raised to the power of negative 1/2 times 9 to the power of 9 raised to the power of negative 1 times 9 to the power of 1/2. The exponents are added. The exponents are added because the bases are the same. So, 9 to the power of negative 1/2. Obviously, negative 1 times 1/2 is equal to negative 1/2. So, that's 1 over 9 to the power of 1/2. That's 1 over 3 squared raised to the power of 1/2. So, that's 1 over 3 raised to the power of 1. The exponent of 3, which is now found in the denominator, is 1. since 2 times 1/2 is equal to 1. The answer is 1/3. Thank you.